All right, question for you. Are you ready for a holographic reality? I'm talking about a world so deeply immersed in extended reality that you could literally just pop into a meeting as a high-fidelity hologram. Or, get this, doctors flawlessly performing high-precision remote surgeries from thousands of miles away. Now, I know, it sounds straight out of a sci-fi movie, right? But believe it or not, this future is coming at us fast. So, welcome to this explainer. Today, we're going to unpack the absolute mind-bending technological leap that is 6G. But we've got to balance that out by looking at the rather harsh, frankly fragile reality of the digital infrastructure we're using right now. We're staring down a future with a physical, digital, and biological worlds just totally merge. But we absolutely have to ask ourselves, are the systems we rely on today just way too vulnerable to handle the whole shebang? Okay, let's dive right in. Section 1, the 6G revolution. So, standardization work for 6G is actually expected to kick off by 2025, with commercialization hitting somewhere around 2030. It's wild when you trace how mobile networks have evolved, right? We started out with 2G's basic voice calls and texts. Then 3G gave us the mobile internet, 4G absolutely fueled the social media and video streaming boom, and right now we're living in the 5G era of the industrial Internet of Things. But 6G moves us way past all of that. It's essentially a distributed, intelligent network, underpinned by massive-scale AI, and its goal is to literally connect our entire physical and biological worlds. It's a real game changer. Now, to really grasp why we even need 6G, we kind of have to look at the roadblocks we're hitting today. You might be sitting there thinking 5G is plenty fast, but industry reports actually show that our current 5G user experience just isn't cutting it for seamless, fully immersive, extended reality, or XR, streaming to really take off. 6G promises to absolutely blow past those limits. We're talking about speeds up to 100 times faster than 5G. Seriously, they're aiming for a peak data rate of an unbelievable 1,000 gigabits per second. No way, right? So, what does all that insane speed actually get us? Well, 6G is basically conceptualized as this massive triangle merging physical space, cyberspace, and intelligence. Because it has near zero latency, this speed is going to enable something called digital twins. Basically, a digital twin is a flawless, real-time virtual replica of a physical thing. Imagine building a digital twin of a super complex jet engine, so you can monitor wear and tear in real time without ever taking the actual engine offline. Or, and this is where it gets crazy, mapping a digital twin of a human immune system. The level of interactivity here is just completely unprecedented. Section 2, the centralization trap. Okay, before we get completely lost daydreaming about this utopian 6G future, we really need a reality check on our present. Take this number, $200 million. That represents a massive cryptocurrency exchange hack that recently went down in India. Over 1 million users were robbed. And what this really exposes are the deep inherent vulnerabilities in centralized custody infrastructure. You see, when huge amounts of digital assets are stored all together in one place, it's like a giant target. It creates scaled risk and massive single points of failure. And frankly, this isn't just a crypto problem. Just look at the terrifying domino effect of the global outage we saw back in July 2024. A single, literally just one, defective software update from CrowdStrike knocked Microsoft Azure services completely offline. Because so many global sectors lean heavily on that one centralized cloud infrastructure, the fallout was pure chaos. Global travel, severely disrupted. Banking took a huge hit. Broadcasting was literally taken off the air. So the crucial takeaway for us here is that relying on centralized operations creates catastrophic global risks. Single points of failure are actively, right now, bringing down our hyper-connected world. Section 3, the decentralized solution. So these current systemic failures really expose an urgent need to totally shift our digital frameworks, especially before we deploy something as massive as 6G. We need decentralization. By definition, this just means distributing data and processes across multiple nodes. Basically, by not keeping all your eggs in one basket, you fundamentally slash the risk of a single point of failure. If one node goes down, the system survives. It's that simple. This boosts overall resilience and security, scaling up perfectly to prevent those massive chaotic failures we just talked about. And actually, in sectors like finance, this shift is already underway. We're seeing a massive push toward native on-chain asset management, self-custody, and decentralized finance, what we call DeFi protocols. These systems perfectly embody those decentralized principles we just went over. Now, to be fair, they do have their own risks, like code breaches that require really strict auditing, but structurally, they completely eliminate those massive centralized honeypots that end up costing users hundreds of millions of dollars. Section 4, Securing the Future. This whole mindset of resilience absolutely has to be baked directly into the architecture of 6G, and not just to fend off cyber threats, but to tackle environmental strain too. Did you know the tech sector already uses up to 9% of the entire globe's electricity? Every time we upgrade to a new network generation, efficiency improves, sure, but then a massive surge in data traffic basically wipes those efficiency gains right out. So the target for 6G is incredibly ambitious. It has to somehow cut 5G's average power consumption in half, all while supporting peak capacities that are 10 times higher. They're actually looking into harvesting ambient energy, like literally using the thermal friction from rubbing your hands together to power zero-energy IoT devices. Mind-blowing, right? Now, to handle the security side of things, 6G has to be secure by design from day one. There are 3 absolutely critical technological innovations being cooked up right now. First up, quantum key distribution. This uses quantum mechanics to establish unhackable encryption keys at both ends of a communication line. Second, integrating blockchain technology to lock down privacy, which lets people use pseudonyms instead of actual identities during these massive data exchanges. And third, utilizing AI-based threat detection. This is AI that continuously learns and adapts to neutralize cyber attacks long before they ever get the chance to spread. Section 5. The global 6G race. With an estimated €3 trillion in global economic growth on the table by 2030, there is a massive, high-stakes competition underway to build and dominate this network. Major global powers are quite literally fighting for digital sovereignty. South Korea has thrown down €440 million to secure the world's best 6G technology. Meanwhile, the European Union has established this huge joint undertaking with €1.8 billion in funding. Over in India, they've launched the €1.1 billion Bharat 6G vision. And Japan? They are injecting €520 million straight into their ecosystem. We also definitely have to highlight China's aggressive strategic focus here. According to the sources we're looking at, China actually holds nearly 50% of the world's 6G patent applications. Let that sink in. Their government selected it as a top priority back in 2023, and they are tying this tech directly to their huge ambitions for a Chinese metaverse and large-scale AI deployment. You know, what's really fascinating is how differently these regions are tackling the challenge. The United States is leaning heavily on private sector giants, think Apple, Google, and Nokia, teaming up through the NextG Alliance to drive North American innovation. Now, compare that with the European Union strategy. They are heavily driven by these massive publicly funded initiatives, like the Smart Networks Joint Undertaking, specifically designed to protect European technological sovereignty. So, what does this all mean? Well, that brings us to our final thought. We are rushing headfirst toward a world where holographic telepresence, biological digital twins, and autonomous societies are just everyday realities. But as we've seen today, connecting absolutely everything also increases the risk of losing absolutely everything to a single point of failure. So I'll leave you with this question to chew on. As we stand on the brink of this incredible revolution, will 6G become our ultimate sixth sense, an invisible fabric that perfectly enhances human existence? Or, if we fail to decentralize and secure it, will it become our biggest systemic vulnerability yet? Thanks so much for hanging out with me for this explainer, and remember, keep questioning the systems that connect us.